This is Module 4.1 PSN-1000 installation. On any of the PFC-6000 series panels, you can install up to 31 PSN-1000s. Each one of the PSN-1000s has a built-in isolated P-Link repeater. You can run 6,500 feet of P-Link wire between each PSN-1000, which gives you quite a bit of distance. Each PSN-1000 comes with 10 amps of power that is usable for its 6 programmable notification appliance circuits, as well as 2 programmable dry contact inputs. You can wire these circuits Class A or B, as well as the P-Link connection coming into the PSN-1000. The PSN-1000E allows you to install 6 stacker brackets inside the cabinet. We're going to start by talking about the cabinet installation. What it boils down to is these are computers, so these need to be mounted in a conditioned space, or as conditioned as possible. So on an interior wall in a conditioned space, they will operate between 32 degrees Fahrenheit and 120 degrees Fahrenheit. And also make sure that the panel is properly grounded. Looking at the PSN-1000, this cabinet has the dimensions of 16 inches by 17 inches by 3 7/8. You can fit 2 18 amp hour batteries inside the cabinet. These cabinets are not deep enough for 12 amp hour batteries. The PSN-1000E allows you to install up to 6 stacker brackets. In this picture you can see one of them is installed. With 6 stacker brackets installed, you still have room underneath them for 2 18 amp hour batteries. Again, this cabinet is not deep enough for 12 amp hour batteries. The dimensions of this cabinet is 26 by 17.6 by 3 3/4. Looking at the electrical specifications for the PSN-1000, these panels will operate on 120 or 240, and that is field selectable by a jumper that is located on the power supply. These panels do need to be connected to a dedicated circuit, that is usually the life safety circuit. The terminal blocks will accept up to 12 gauge solid wire. The 120 connection or 240 connection is labeled hot neutral ground B, W, and G. Turning our attention to the battery connections, the charging voltage is approximately 27.3 volts. If you measure that with a meter, you should read 27.3 volts. If you do not read 27.3 volts, there is probably something wrong with the charging terminals. If you do, there might be something wrong with the batteries. As previously mentioned, the cabinets will hold 2 18 amp hour batteries, and these panels will charge up to 55 amp hour batteries. If a larger battery is required, a battery back box can be purchased. The battery calculation tools are found on our website. There's one specifically designed for the PSN-1000. Normal standby power is 24 hours with 5 minutes of alarm. Now we're going to look at the terminals just to the left of the battery connection. The PSN-1000 has 2 treble contacts next to the battery connection. These treble contacts indicate a system-wide treble and a system-wide low AC. This power board is the same power board from our conventional power supply. In a conventional power supply, these contacts are very useful. On a smart power supply, like the PSN-1000, when there is a condition on the power supply, a trouble condition, a loss of AC, anything like that, that information is relayed through the P-Link connection, the 4-wire P-Link connection, back to the fire alarm control panel. So it is not necessary to monitor these 2 contacts. However, they are there, so in the event that you would like to use them, they are system-wide treble and system-wide low AC, which means when you monitor the treble contact, that treble contact will change states when there is a trouble anywhere on the system. So if somebody pulls a smoke detector head out of a base, creating a trouble at the fire panel, this contact will change state because there's a trouble somewhere on the system. Same with the low AC. When there's a loss of AC, dedicated power to some panel on the system, and there's a low AC condition at the fire panel, this contact will change state. They are rated 3 amps at 24 volts and 3 amps at 120. We are now going to look at the terminals on the right-hand side of the board. Each PSN-1000 has 2 programmable dry contact inputs, 6 programmable Class B NAC circuits, which can translate to 3 Class A NAC circuits if needed, as well as an isolated P-Link repeater. You'll notice just to the right of this we have another P-Link connection. This is always where you come into the panel with a P-Link connection from your previous P-Link device. So for example, coming in from your previous P-Link device, you would connect to this P-Link connection in the PSN-1000. Now if you wanted to go on to another P-Link device, a stacker bracket card, or a remote annunciator, you can come off those same terminals to your next P-Link device. This P-Link connection has 1 amp and can go 6,500 feet. If you want to add distance and power, you can use the isolated P-Link repeater, which is just to the left of this P-Link connection. Still coming in to the P-Link connection on the right, you can now go out of the P-Link connection on the left. This connection is going to give you an additional 1 amp and an additional 6,500 feet to your P-Link devices in the field. So for example, you can take the P-Link connection off the 6800 to a remote annunciator. From there, let's connect the P-Link connection to a PSN-1000E coming into that first set of 4 terminals, labeled P-Link. From there, we can then connect to, say, a stacker bracket inside the PSN-1000 connected to that isolated P-Link repeater. As I mentioned before, we can still connect devices to the P-Link that started at the PFC-6000. We have 1 amp and 6,500 feet, so I'm going to continue that on to an accessory cabinet and a stacker bracket that's installed in that accessory cabinet. I can also extend the P-Link from the PSN-1000E. This is now the isolated P-Link. This connection, the yellow connection here, has 1 amp and 6,500 feet, and I've got it connected to a stacker bracket, now a remote annunciator, and from there, potentially another PSN-1000E. I can then continue on from this PSN-1000E, either from the initial P-Link connection, the yellow connection, or I can start a new connection off the isolated P-Link repeater, which would allow me to go another 6,500 feet and allow me to have another 1 amp of power. The other thing to consider here is the battery calcs. Determining which devices are connected to which P-Link will help distribute the battery requirements for each panel. For example, on the PFC-6000, when you're doing the battery calc tool, it'll ask you what is connected to the P-Link of the 6800. In this case, what is connected to it is an RA6500, a PSN-1000E, and a stacker bracket card that is installed in the AE8. The PSN-1000E on the left, when we do that battery calc, what is connected to its P-Link would be a stacker bracket that's mounted inside the cabinet, the RA6500, and another PSN-1000E. Doing the battery calcs this way, or distributing your power across the P-Link, will allow you to keep your battery sizes down for your backup batteries. Looking now at the 2 dry contact inputs and the 6 NAC circuits and how they can be configured. We're going to start with the output configuration of the NAC circuits. These NACs are each rated 3 amps, and when wired Class B, they need an end-of-line resistor of 5.1K. The power is supervised and regulated, and if they are a horn strobe or strobe circuit, they reverse polarity upon activation. These circuits can be configured as any of the following things: NAC general purpose, aux constant, aux resettable, aux door holder low AC drop, aux ANSI, city tie, Potter sync, Gentex sync, system sensor sync, and Wheelock sync. In the software, each circuit can be programmed as any of the things in this list. NAC general purpose is a general purpose NAC circuit that follows the output pattern as programmed in the software. Aux constant is a 24-volt DC constant power circuit. Aux resettable is a 24-volt power circuit that resets when the panel is reset. Aux door holder is a 24-volt power circuit for powering magnetic door holders. It automatically drops on any alarm and when there is a loss of power to the system. Aux door holder low AC drop is a 24-volt power circuit for powering magnetic door holders. It automatically drops power on any alarm. In contrast to aux door holder, it can be programmed via the software to stay energized when there is a loss of power on the system. The installer can program the time the panel keeps the circuit energized in a low AC condition. The time periods are 15 seconds, 1 minute, or 5 minutes. This is a great feature for projects where a generator is in place to supply backup power on the loss of AC. The 15-second setting can bridge the gap between the loss of AC and the generator starting up. Aux ANSI is used with the ASB or the addressable sounder base. This 24-volt power circuit provides an ANSI temporal pattern for the ASB. City tie is used for municipal box connection if that is used in your area. There are also 4 different synchronized strobe circuits that you can choose from. Potter has built-in synchronization for Potter devices, Wheelock, Gentex, and system sensor. Because each circuit can be individually configured, you can have a circuit of Potter, a circuit of Wheelock, a circuit of Gentex, and a circuit of system sensor, and all the strobes will synchronize. We've called that quadrisync. When wiring the NAC outputs on a PSN-1000 for notification circuits, if they are wired Class B, they need a 5.1K end-of-line resistor. You can also wire these circuits Class A, in which case the upper terminal is going to be the return terminals for that circuit. So for example, 5 and 6 go together, 3 and 4 go together, and 1 and 2 go together to make 3 Class A circuits. These circuits can be independently configured, so you can have a circuit for ANSI, you can have a circuit for door holder, you can have a circuit for resettable power, and then you can have circuits for Potter sync, Wheelock sync, Gentex sync, and system sensor sync. Each one of them is individually configured through the software. And this has system-wide synchronization, which means if you have strobe circuits connected to a PSN-1000 as well as strobe circuits connected to your fire panel and maybe strobe circuits connected to another PSN-1000, all those strobe circuits will synchronize without pulling a sync cable. The synchronization occurs over the P-Link circuit. Now looking at the 2 dry contact inputs on the PSN-1000. Through the software, you decide what that contact input is monitoring. Your options are as follows: contact input pull station, water flow, supervisory, tamper, fire drill, trouble monitor for monitoring a trouble condition, aux for monitoring an auxiliary or alarm condition, reset, silence, fire alarm, again for a fire alarm condition, disable inputs, disable outputs, disable inputs and outputs, lamp test, contact input CO alarm, and contact input CO supervisory. This list is found in the programming software, and each circuit is individually configured depending on what you are monitoring. So for example, if I want to monitor a conventional duct detector for a supervisory condition, I can set up the I circuit to be contact input supervisory. If I wanted to monitor a CO detector with one of the I/O circuits and I wanted that to be an alarm condition, I would set up the I circuit as contact input CO alarm. Disable inputs, disable outputs, and disable inputs and outputs are used for monitoring a key switch or switch that when activated would disable the inputs that are assigned to the same software zone as the I/O circuit, or disable the outputs that are assigned to the same software zone as the I/O circuit, or disable both inputs and outputs in that same software zone. For information on programming that type of functionality, please refer to the recorded module on input and output disabling functionality. Taking a look at the wiring of the I circuit, these circuits cannot exceed 100 ohms or 10,000 feet. They need an end-of-line resistor of 5.1K ohms. Multiple dry contacts can be monitored on an I circuit depending on the dry contact type. For more information on the PSN-1000 installation, wiring, and program, please refer to the other recorded modules. The next module is Module 5, SLC devices.